When you boot the VM that has been given to you, you should see a screen like this. The VM already comes preloaded with some practice code in the Vision folder. So when you go to the Vision folder, you should see these folders: OpenCV, practice, practice2. If you don't see the practice or the practice2 folder, there's no problem. You should be able to download these from the course website. Now let's go into practice2 and explore this code, see what it does. The practice2 code has the folders bin, sample inputs, sample results, source, and the CMake lists file. The source code in this folder contains the code to do run-length encoding of black and white images along the rows, dilation of images, and erosion of images. Let's compile the code. Let's go to the folder. Okay, now this is empty. So I'm first building the project using CMake. You've already seen how to use CMake. If you have not seen how to use CMake, I would urge you to go through that tutorial first. So CMake has finished executing. Now I'm going to build the code. So I finished building the code. Right, there are three source files: morphology.cpp, homework.cpp, and logmanager.cpp. Homework.cpp, morphology.cpp. You also have the corresponding .h files, and you have log manager. In earlier tutorials, there might be a chance that this file was called by a different name, but the functionality remains the same. Now let us see how to run this code. So let's see the command line arguments. So the command line arguments are like this. There are three options: /homework, run-length-encoding row, RLE row, /homework dilate, /homework erode. So this is for extracting run-length encoding row wise. This is to dilate the image, this is to erode the image. So let's run these commands one by one and see the outputs. And there is a sample image given in the sample inputs folder. So there is a sample image given here. So let's run through this image. So let's see what happened. So we finished executing this. Let's go to the temp folder. See, we have given the path as the temp folder, right? Let's go to the temp folder and see the result. So you have a log file that was generated. Let's open this log file. And there is a run-length encoding file also which has been created. So this is the run-length encoding result file which has been generated. Now this file should be identical to the result that has been supplied to you, the sample result that has been supplied to you. So this and this file should be identical. So this result that is obtained should be exactly the same as RLE rows. So let's compare this and find out. So the result file was in the temp folder, right? So this was the file. Let's compare it with the sample result that has been given. So the diff command allows us to compare it. There's no difference. So these two files are identical. Now remember, in your assignments, when you submit your code, we will expect you also to be implemented functions like this. So far in the previous demos, we have shown you code in Emacs. We have also created an Eclipse environment, Eclipse project within the Eclipse environment. Let's open Eclipse and browse through this project. So as Eclipse is loading, I would like to point out to you, you can use Emacs, but I would strongly suggest don't install any other IDEs. Do not submit project files created by IDEs. Each assignment will tell you exactly what are the files that you need to submit. So only the source files and the output files, if any, should be submitted. So we have already loaded practice 2 into Eclipse. So you should see the code like this. So the function that we just executed, the run-length-encoding function that we just executed, was in the file morphology.cpp. Right, so this was the morphology.cpp function. And we just executed this. And how did this get executed? If you go to homework.cpp, you can see the top level function that got called was the main function. In the main function, you compared the input arguments with RLE row. So you first go into this loop. You check whether the number of arguments is greater than 2 or not. And if that's true, you come here, right? And you compare the command line arguments. So when you compare the command line arguments, the command line argument that we gave was this: homework RLE row sample inputs, right? So RLE row was the sample, command line argument that we gave. So the first argument is this image path, or rather the third argument is this image path, which gets read here, and that is assigned to input image path. The last argument is the output folder path, which gets assigned here, and then you call the morphology get run length encoding function, and this takes you here. The morphology get RLE of rows for black and white image computes the run length encoding for black and white images. It takes in as input an input image path and an output folder path. And the first thing that it does is it writes a message to the log file. By now you should have already become familiar with how to use the log manager or a logger in C++. If you are not familiar with it, I would strongly recommend that you should go through the tutorial. But one thing you would have noticed that even while we are calling this log message, nothing was getting printed to the log file. So let's just look at the log file. Nothing is getting printed to the log file. The log file has been reset because we called log manager reset log file. But this message is not getting printed. Right, so what is this message? This message says starting morphology get RLE of rows for black and white image. Right, this line has not been printed in the log file. So let's see why that is not getting printed. So let's go to util and load these files. And let's look at the function isLog disabled. So when you go to isLog disabled, there is no entry for morphology. So we need to create that entry. So let's create that entry here. So we are reading we are copying the function name and pasting that here. Right? Let's copy the entire function. And let's save all the files. Right? And now let's compile the code and see whether the log file gets generated. So I'm going to compile the code again. Okay, the code is compiled, and let me run the run length encoding. So I'm just running the command line arguments. Now let's load the log file once again. Yes, so the log file entries got created. So make sure whenever you implement a certain function, if you are using log file entries, you need to enable them in the log manager. Right? In isLog disabled, you need to add lines like this. And overall, if you are not familiar on how to use the log manager, please go through the tutorial that we gave you earlier in the course. Now after this, the code reads the input image. If the input image is empty, then we throw an error. Again, there was a tutorial that we pointed out to you earlier. You should go through the tutorial to understand how to throw different exceptions and errors, and how to create your own exceptions and your own errors. After reading the input image, it's printing out a message saying that it has finished reading the image. If the image is RGB in color, the image is converted. These lines convert the image. And then the run length is computed. So this code computes the run length. And it also prints the run length into an output file. So what is the output file to which the run length has been printed? See, the run length has been printed like this. The run length encoding output file is getting created like this. So the file is here, rleros.txt, and we add that to the output folder path. So the output folder path is an input to this function that is getting added to this, and the run length encoding results are being written to this file. Therefore, when we give at the command line this option /temp/res, the result is written into this particular file, right? So the entire file name is this. Please make sure you don't modify this whenever you're implementing your assignments, whether it is for run length encoding or for any of the assignments in the future. We will also tell you in case we want multiple output files, and this has already been told to you earlier in the previous sections of the tutorial. So make sure that you follow those instructions very clearly. If your output files are generated in the wrong locations, or you change these file names, we will not be able to automatically grade your assignments. Let's run the erode and dilate functions as well. So the same input image, and we are running the erosion code. Let us see the result. This is the result of erosion, and let's look at the input image. This is the input image. This is the input image. This is the result of erosion. Let's run dilation now. This is the dilation result. So we will expect you to implement functions like this in your assignments, and you can reuse the project that we have given to you. So you can add or edit files that have already been added to this particular project. This will allow you to edit your code easily. You can compile your code from the command prompt. By now you would all be familiar with how to build the project using CMake and compiling your code using make. You would also be familiar with the logging framework that we discussed and the try, throw and catch block of C++. We also showed you that you can use either Emacs or the IDE Eclipse, which we have already installed on the VM that has been given to you. Please note that command line arguments are important. The format of the command line arguments is important because that's how we will be grading your assignments. We will have scripts that run your code against test images or test data. The output file formats also are expected to be in a certain way, and we showed a few demos of that as well. So make sure you stick to these, and each of your homework assignment will be specifying what kind of inputs will be given, the command line arguments will be given to your code, and what kind of outputs will be expected. I hope you'll all enjoy coding the assignments. Thanks everyone.